Hi, my name is Ajat Zafri bin Zainuddin. So today I would like to present my project for the NIICE 2022, and my title is Traffic Analysis Using Deep Learning and Deepsort Algorithm. My supervisor is TS Sharifah binti Saon, and my co-supervisor Prof. Madya IR Dr. Abdul Kadir bin Muhammad. So, introduction. Smart traffic can be categorized as a system that can effectively manage traffic to avoid or reduce congestion. So, one of the techniques is the blending, because it is widely used to identify moving object in the videos. And CNN-based approach have the advantage of the deep architecture to create non-handcrafted features accurately to represent objects. And the main target for this project is to analyze vehicle speed, vehicle time, and vehicle count. And then the data from this system can be utilized and used by the authority. For example, some company can use it to analyze traffic congestion in an area. So the problem statement is number one is number of cars is increasing each year, and common situation as can be seen in the traffic light junctions where the cars line up waiting for the green light. And next is traffic congestion. The objective is number one to develop a vehicle type and counting system using the Deepsort algorithm. Second one is to develop a vehicle speed system using the delay correlation tracker, and the last one is to evaluate the performance of the development system. And the methodology is we are using a software which are Google Colab and Visual Studio. We are using Python as a language, and then we we are using the library TensorFlow and OpenCV, and also we are using the YOLO V4. Then there is the flowchart for the vehicle counting, and then there is a block diagram for the vehicle detection. So the demonstration. So after we run this code, so the system will start do the process, which is, if you can see, we get the average FPS is around 29. Then you can see at this part the system start to recognize the our vehicle. So you can see at the result. So this is the result for the daytime. So we can see the system will detect the car, truck, and if the motorcycle, this part, if you can see for this, the motorcycle, the system detect the motorcycle and the person. So is all the code, and then we go to the our result. So if you can see in this part, we have the analysis for the rainy weather. So we run the code and we run the video, and we can see the system is start detecting the vehicle and start counting the vehicle. So at the right, at the left side, we have object being detected, being tracked. So it shows 11. It is because the once the system is detect and show the boundary box, so it will count. So for example, at this frame we have 11 object that we track by the system. So and then for this part we have the total of vehicle, and we have two sides, which is the upside and the downside. So you can see the system already count the car, which is 8, and motorbike 1. Okay, we can see at the end of this video we get the result. Car is 76 and motorbike is 3, bus is 1, and the truck is 3. So that's all for the vehicle count. So the last parameter is vehicle speed estimation. So we are using the Visual Studio Code software. The reason why we use this software is you want to use this delete library because at the Google Colab the delete library is not acceptable. So we try to do this code and run this code using the VS Code. So basically how to run the code is we have to set up several library, which is the delete library and OpenCV library. So after we set up all the library, then we and then we run the code. This is our result for the vehicle speed. If you can see, the speed is not relevant because mostly at the traffic light junction the vehicle speed is around 30 or 40 kilometer per hour. So if you can see, we get 7, 14, 10 and so on. So the accuracy of speed is low. So this the result. And then next is the finding. So for the finding is for the objective number 1, we can see for this vehicle detection during daytime we don't have any problem, same like the during night time. And we have one problem at this part during rainy day. We can see the system track a bus truck as a bus. Okay, this for the vehicle count during daytime. You get the actual number is 16, but the system detect 18 because the system detect another object as a car. Then this for the night time. Okay, this for the rainy day, same problem like before this. Okay, and then objective number 2. Okay, if you can see at this picture, the speed range is from 7 to 29 km per hour. However, the result shown is irrelevant since this is a highway road. This happened because of the limitation of getting accurate result is using graphic processing unit GPU. With a slightly higher GPU specification, this problem can be mitigated. So the objective number 3. So we can see for the average accuracy vehicle detection, we get the time is 100%, night time is 100%, and the rainy day is 50.95%. The total average 83.65%. And then for the average accuracy for vehicle count is for the daytime is 52.6%, nighttime is 49.75%, and the rainy day is 95.6%, and the total average is 65.98%. So contribution to society. This project practical contribution to analyze traffic congestion at the traffic light junction. It can help the authority to reduce traffic congestion based on 3 parameter analysis, which are vehicle speed, vehicle time, and vehicle count. So that's all. Thank you.